Let us define the term momentum. When Newton was thinking about motion and when he was formulating his laws of motion, he did not think of objects in motion in terms of their energy, in terms of their kinetic energy. In fact, the term energy hasn't been discovered yet. No one used, no one thought of object in terms of what we now call energy. Yet Newton realized that moving objects that have mass, that are in motion, have a certain property that is different from objects that are stationary. If you have a large rock falling down a hill, it can do a lot of damage down below the hill. Today we would say that it has a lot of kinetic energy, but Newton didn't think of objects in terms of energy. He realized, though, again, that a falling rock has a certain property which a rock that is stationary doesn't have. And he also realized that how much of that property the falling rock has depends on how heavy the rock is and how fast the rock is going. He called that property momentum, and he postulated that the momentum of an object is equal to a quantity given by the mass of the object times its velocity. An object can have a really large momentum if it has a large mass and is moving very, very fast. But even with small mass, if the object is going very, very fast, it can have a lot of momentum. It will, of course, have also a lot of kinetic energy. But this quantity, mass times velocity, is still, what you call momentum, is still very useful, especially when we are considering collisions of objects. So we still use momentum, and momentum is closely related to impulse. So we're still going to be using momentum. Mass times velocity equals momentum. To get large momentum, multiply small mass by a really, really large velocity. Or you can have a huge object moving slow. It still has a lot of momentum. If you think about a big boat, a big ship, a tanker, fully loaded with, a lot of cargo, it can be going very, very slow, but because of its large mass, it still has a lot of momentum.